Hello, hi everyone. Welcome to the next video of this series. In this video, we are going to discuss some previous year questions of chemical bonding and molecular structure. But before doing the questions, let us know who will get benefit from this video. So this video is for those students who knows the basics, who has NCERT level knowledge and has taken coaching somewhere, because all the concepts are very important when you apply, right, in the questions. Okay. Now, how to use this video? You have to revise short notes, you have to read the NCERT, you have to write down the important information, and then you can start doing the questions with me. Okay, so here in this video, when I am going to do question, when I solve some questions, then I will provide some basic knowledge of that particular topic. Okay, now what we are going to discuss in this video? First, we are going to discuss the weightage, then syllabus, mind maps, and previous year questions in terms of problem types, obviously. Now, if we talk about the weightage, so weightage, we have almost two questions, right? Almost two questions in every set. In some set, there is one question, but normally we have two questions on an average. What are the high priority topics in this? All the theories of chemical bonding: VBT, Vesper theory, dipole moment, and MOT. Dipole moment is not the part of the theory, but there are so many questions which come from this topic, that is the dipole moment. So you should have good grip on these topics, right? So let's discuss the mind map first. So in the chemical bonding, first we have to discuss the types of bonding. First you should know the types of bonding, and in the types of bonding we have generally three types of bonding: covalent bond, ionic bond, and the coordinate bond. Coordinate bond is also known as the dative bond. So what you should know about all these type of bonding, what are the basics of this bonding, right? What are the basics of this bonding? What are the characteristics of this bonding? What are the properties of the compounds which are formed by these kind of bondings, right? What are the properties of the ionic compounds? What are the properties of the covalent compounds? How to draw the covalent bond in the covalent compound. So for this part, you should have a good grip. You should know how to write down the Lewis dot structures and all. Okay. Now, then we have another part of this. Like in the bonds, we have other types of bonding like back bonding. What are the characteristics of back bonding? In which compounds we can have back bonding? Like BF3, in BF3, in BCl3, we can have the back bonding. Then we have different bond like bridge bond. So in which compound bridge bond can form, right? What are the characteristics of bridge bond? What are the conditions which are required in order to form the bridge bond? So that's the important part. Then we have another type of bond, that is the hydrogen bond. How does hydrogen bond form in between two atoms? That you should know, right? Then you should have the idea about the types of hydrogen bonds in terms of intermolecular hydrogen bonding and intramolecular hydrogen bonding. That's a very important topic. Then we will move to the theories of chemical bond, and in theories of chemical bond we have different bond formation theory. So first bond formation theory is as per the octet rule. Now what is octet rule? If we have any compound which exists, right, which is stable, then all the atoms in that compound should have 8 electrons in the outermost shell. That is the important part. But that theory is not applicable to all compounds, to all molecules. So we have some limitation of octet theory. That's why we have different theory, that is the VBT, valence bond theory. So in the valence bond theory, we have the overlapping concept. Like if s orbital overlaps with the s orbital, then we have the ss overlapping. If s orbital overlaps with the p orbital, then we have sp overlapping. So similarly, we can have different types of overlapping, PP overlapping, and on the basis of these overlapping, we have different categories. We have different categories of bond. Like if there is the head on head overlapping, or we can say axial overlapping, so bond formed is basically sigma bond. Okay, now if we have sidewise overlapping like this, so if we have the sidewise overlapping, then sidewise overlapping, say we are going to form the pi bond, right? We are going to form the pi bond, and pi bond, in the pi bond we have sidewise overlapping, or we can say lateral overlapping. If we have phase-wise overlapping, then we have the concept of the delta bond, right? But delta bond is more important to the advanced level, but sigma bond and pi bond, they are important with respect to the JEE Mains. Okay. Now, then we have the Vesper theory, that is valence shell electron pair repulsion theory. In the valence shell electron pair repulsion theory, we can find out the shape of the molecule. We can find out the shape of the molecule. What is the shape of the molecule? And if I want to find out the geometry of the molecule, then we can go to the hybridization. Hybridization is nothing. It is a hypothetical concept, or we can say it's a mathematical concept. So from the hybridization part, we can predict geometry, right? And how to calculate hybridization? So we have two ways to calculate hybridization. Steric number. First is the steric number. So how to calculate steric number? I will discuss the formula later on. And from that hybridization, you can first find out the geometry, and then you can find out the shape. Okay. So for this part, you should know, basically you should have the good knowledge of all these topics. Then you can do the questions in no time. Otherwise, it will be very difficult for you. Then the last topic, we have molecular orbital theory. So in the molecular orbital theory, what are the important points that you should know? Like, you should know how we can form the bonding molecular orbital and the anti-bonding molecular orbital. And we have the notes in bonding molecular orbital or anti-bonding molecular orbital. So what are those notes? What is the position of those nodes, right? And then we have, you have to understand, and you have to know the electronic configuration of homoatomic diatomic molecules. Homoatomic diatomic molecules. Then you should know the electronic configuration of CO molecule, NO molecule, and on the basis of electronic configuration, how to calculate the bond order, how to compare the bond length. So that is the important part. And one more thing, how to know the magnetic behavior, how to know the magnetic behavior of that particular species, of that particular molecule, in terms of paramagnetic and diamagnetic. So these are the important parts with respect to MOT. So before starting with the question, please go through all these topics at once, and then you can start doing the question. So up now, I have discussed almost every important aspect of this chapter. Now let's start doing the question. So let's do question number 1. The correct increasing order for bond angles among BF3, PF3 and ClF3 is. So in order to find out the bond angle, first step is to find out percentage S character. And in order to find out percentage S character, you should find out hybridization. You should find out what? Hybridization. Why? Because percentage S character is directly proportional to electronegativity, is directly proportional to bond angle, it is inversely proportional to bond length, and directly proportional to bond strength. Bond strength. Directly proportional to bond strength. So it means in order to find out the correct order of bond angle, first step is to find out the hybridization. Now, how can we find out the hybridization? So, for hybridization, we have to calculate steric number, right? We have to calculate steric number. So, how to calculate steric number? Half number of valence electrons of central atom plus number of monovalent atoms, monovalent atoms minus magnitude of positive charge plus magnitude of negative charge. Okay, magnitude of negative charge. So this is the formula to calculate the steric number. So let's use this formula in order to calculate the steric number of the given compounds. So we have BF3, PF3 and ClF3. Okay, so let's find out BF3 steric number, half. So central atom over here is boron, and if central atom is boron, so what are the valence electrons? How many valence electrons are there in boron? So boron atomic number is 5, so we have 3. Fluorine is the monovalent. Why? Because the valency of fluorine is 1. So we get plus 3 into 1. So total 6 by 2, steric number is 3. Okay. Now similarly, we can find for PF3. So PF3, half number of valence electrons on phosphorus present in phosphorus is equal to 5 plus 3 into 1, which is equal to 8 upon 2, 4. Similarly, let's calculate for ClF3. So ClF3, half number of valence electrons in chlorine, 7, 3 monovalent. So we get 10 by 2, 10 upon 2, 5. And now, if we know the steric number, then we can find out the hybridization. So see, if this steric number is 2, then hybridization is sp. If steric number is 3, hybridization is sp2. If steric number is 4, hybridization is sp3. If steric number is 5, then sp3d, 6 sp3d2, and for 7 sp3d3. Okay, so now if I write down the correct hybridization with respect to the given molecule, then in BF3 we have sp2 hybridization, PF3 we have sp3 hybridization, and ClF3 we have sp3d hybridization. So now in which one we have more percentage of S character? Obviously in sp2 we have more percentage S character. How to calculate percentage S character over here? So see, we have 3 orbital, 1s and 2p orbital, 1s and 2p orbital. So we can say total percentage is 100 and only 3 orbitals are involved in this hybridization, to 100 divided by 3. So we can get around 33.33 percentage. In order to calculate sp3, then we have 4 orbitals which are involved in sp3 hybridization, 1 orbital of s and 3 orbitals of p. So we can write down what? 100 divided by 4. So here we have 25%. Similarly, we talk about sp3d. So in sp3d, 5 orbitals are involved. So it means 100 by 5. So 20% S character. So bond angle is directly proportional. Bond angle is directly proportional to the percentage S character. Bond angle is directly proportional to percentage S character. So more percentage S character is in BF3. So BF3 more bond angle, and the least percentage is in ClF3. So least bond angle. So as per this, option number C is the correct answer. Option number C is the correct answer. Now let's do the next question. In which one of the following pairs the central atom exhibit sp2 hybridization? How to do this? We have to calculate steric number for that. So see, we have BF3 and NO2 minus. So let's calculate for BF3. So half valence electrons in boron, 3 monovalent atoms. So total 3, and 3 is equivalent to sp2 hybridization. Now similarly, let's calculate for NO2 minus, half nitrogen valence electron 5. We do not have any monovalent atom. Why? Because oxygen is divalent. Oxygen valency is 2. This is 2 comma 6. So the valency of oxygen is 2. So no divalent. But negative charge is there. So we have to add the magnitude of negative charge. So by doing so, we get 6 by 2, which is equal to 3. So here it is also sp2 hybridization. So it means we have option A is the correct answer. Now let's check for other options. So for example, in BF3, so we have sp2 hybridization. Let's check for NH2 minus, half, number of valence electrons in nitrogen 5, monovalent atoms 2, plus magnitude of negative charge, so plus 1. So we have 4. So this is sp3 hybridized. So answer is B cannot be the answer. Now C, in C we have H2O, which is different. So H2O, central atom is oxygen, valence electron in oxygen 6, 2 monovalent atoms, so 2. So again 4, which is sp3, which is sp3. Now let's calculate for NO2. NO2, NO2, half, 5. That's it. So we get 2.5. Now how, because NO2 is the odd electron species. NO2 is the odd electron species. So steric number is not applicable. Steric number is not applicable to odd electron species. So what we are going to do? So we have a trick to do that. Suppose if central atom is more electronegative than the surrounding atom. If central atom is more electronegative than the surrounding atom, then if we have 2.5 na, so just take it as 2. So it means sp. But if electronegativity of central atom is less than the surrounding atom, so if here we have 2.5 na, so just take it as 3. And for 3, it is going to be sp2. So by doing so, NO2, it is going to be sp2 hybridized. It is going to be sp2 hybridized. Why? Because oxygen is more electronegative than nitrogen. Clear? So answer is 1 for this question. Now let's discuss the next question. So next question, the shape of carbocation is. So what is carbocation? Carbocation means carbon carrying positive charge. Positive charge. So we know that in carbon we have 4 electrons. We have 4 electrons. So 1, 2, 3. But carbon positive, we have only 3 electrons. For carbon, in carbon neutral, we have 4 valence electrons. Na? These are valence electrons. So in carbon positive or carbocation, we have how many electrons? Only 3. So hydrogen, hydrogen, hydrogen. So positive. Okay. So now there is one more way to find out the hybridization. If you know the structure. If you know the structure, then you have to calculate the number of sigma bonds and lone pair in order to find out the hybridization. If you see over here, we have 1, 2 and 3. 3 sigma bonds. So 3 sigma bonds means sp2 hybridized. So if you know sigma plus lone pair summation, right? Then we can also find out the hybridization. How? See, if we have 2, then hybridization is sp. If we have 3, then hybridization is sp2. If we have 4, then hybridization is sp3. If we have 5, then hybridization is sp3d. 6, so sp3d2. And 7, then sp3d3. So we can find out the hybridization via 2 ways. From steric number or from the structure. So in this structure, we have to calculate the number of sigma bonds. So here we have 3 sigma bonds. So sp2 hybridized. And what is the geometry associated with sp2 hybridized? That is the trigonal planar. That is trigonal planar. So answer D is the correct answer. Okay. Now let's do the next question. When psi A and psi B are the wave function of atomic orbitals, then sigma star is represented by. So see, psi A is the wave function for the electron for the electron of atom A, and psi b is the wave function for the electron of atom B. Okay, so now this is the concept as per MO theory, right? This is the concept as per MOT, right? MOT. What is the concept? If two orbitals, or we can say if two atomic orbitals combine, then they form two types of bonds. One is going to be the bonding molecular orbital, and second is going to be anti-bonding molecular orbital. So we get two types of molecular orbital, bonding molecular orbital and anti-bonding. So if we have the sigma bond in between these two atomic orbital, then BMO is going to be sigma and anti-BMO is going to be the sigma star. So in BMO, when we form bonding molecular orbitals, so there is a kind of positive overlapping between the orbitals. So we have total psi is equal to psi A plus psi B. That's a case of positive overlapping. Positive overlapping. Now, when we have sigma star, right, anti-bonding molecular orbital, so in anti-bonding molecular orbital we have to do the negative overlapping, so psi a minus psi b. So that is the concept. That's a negative overlapping. Negative overlapping. Negative overlapping. Now just try to understand key what I am saying. Yeah, what is the meaning of positive overlapping and the negative overlapping? See, if psi a is this, it's a wave function, the positive, negative, positive. This is psi A. And if we have psi B, this positive, negative, positive. So the point is, if this positive wave, positive, right, part combines with the positive one, then that's a case of positive overlapping. But if this positive one combines with negative one, so that's a case of the negative overlapping. That is a case of the negative overlapping. So in the positive overlapping, amplitude of wave increases, amplitude increases. And in negative overlapping, amplitude of wave decreases. Understood? So that's the part. But this is not the question. Question is that the sigma star is represented by how? Obviously, psi A minus psi B. Okay, psi A minus psi B. It means we have to do the negative overlapping. So that is going to be the answer. Okay, now let's do the next question. Match list 1 with list 2. Okay, so this is the question related to Vesper theory, VSEPR theory. Okay, so in order to find out the correct shape and all, we have to find out hybridization first. We have to find out hybridization first, and we can calculate hybridization using steric number. So A option is NH3. So let's find out the hybridization of ammonia, half, nitrogen 5, 3 monovalent. So we have 4. So it is sp3 hybridized. But in sp3, we should be having 4 bond pairs. Here we have only 3 bond pairs, so we can write 3 bond pair plus 1 lone pair. So for sp3, geometry should be tetrahedral, but the shape is going to be the trigonal pyramidal. Trigonal pyramidal. Why trigonal pyramidal? Due to the presence of one lone pair, like N, H, H, and we have one lone pair. So this is the trigonal pyramidal. Now, so for A, it can be matched with option number 3. Okay, A can be matched with option number 3. Now let's do BRFI. Acha, how to solve C? A can be matched with 3 na, so we can have option number B or option number D. And now what is the difference in between option number A and D? So let's find out B only, then we can pick the answer, right? So like BRF5. So if I want to find out the BRF5, so BRF5 hybridization is half 7 electrons plus 5. So that is going to be 12 by 2, which is 6. And 6 is sp3d2. So geometry is octahedral. But in BRF5, we have 5 bond pair plus 1 lone pair. So one lone pair is present, due to which the shape is different. The shape is going to be the square pyramidal. Square pyramidal. Okay, square pyramidal. So it means B option can be matched with option number 1. BRF5, it can be matched with option number 1. So on the basis of that, B option is the correct answer. But let's find out the PCL5 and CH4 geometry also. So PCL5 is going to be half 5 plus 5, then 5, it means sp3d, and we have 5 bond pair plus 0 lone pair. So it means geometry is going to be the trigonal bipyramidal, and trigonal bipyramidal is this. Okay, this is going to be trigonal bipyramidal. Okay, so PCL5 is fourth. Now we have CH4. So CH4 have valence electron in carbon 4, 4 monovalent. So 4, that is equal to sp3, and sp3 means tetrahedral geometry. So we have 4 bond pairs plus 0 lone pair. So the geometry is equal to the shape. So it means CH4, it can be matched with second option. So option B is the correct answer. Okay. Now let's do the next question. Match list 1 with the list 2. So that's again the Vesper theory question, VSCPR theory question. So we have to find the shape and geometry, right? So let's find out for SF4. So SF4, valence electrons on sulfur 6, 4 monovalent. So we have 5. 5 means sp3d. sp3d means trigonal bipyramidal geometry. But if we want to find out the shape, so we have to exclude lone pairs. So here we have 4 bond pair plus 1 lone pair, and lone pair in trigonal bipyramidal, lone pair occupies the equatorial position. Lone pair occupies the equatorial position. Okay, so these are equatorial bonds. Then we have axial bonds. So what is the shape? It is going to be the seesaw, or we can say bent seesaw. Seesaw or bent seesaw. Okay, so A can be matched with third, that is going to be the seesaw. Okay, now let's do the next question. Next part, BRF3. So B is what? BRF3. So let's do it. So half valence electron on bromine 7 plus 3 monovalent. So again 10 plus 2, which is equal to 5 sp3d. But we have 3 bond pair plus 2 lone pair, because only 3 fluorine, 3 surrounding atoms are there. So we have 3 bond pair and 2 lone pair. So lone pair occupies equatorial position. So the shape is going to be T shape. What? T shape or bent T shape. Clear? Or bent T shape. So we can say BRF3 is going to be the fourth. Now for C, BrO3 minus half 7. Oxygen is divalent, but 1 negative charge. It means 7 plus 1, 8 divided by 2, 4. For sp3, it should be tetrahedral, but we have how many bonds? We have only 3 bonds. 3 bonds and 1 lone pair. So it is going to be pyramidal. It is going to be pyramidal. So C is pyramidal. Okay, and ammonium is what? Ammonium is going to be tetrahedral. Ammonium is going to be tetrahedral. So on the basis of that, we can say A option 3, B 4, C second, and D first. So option B is the correct option. Let's find out the ammonium hybridization also. So half nitrogen 5, hydrogen 4, 1 positive charge, so -1. So it is going to be 4 only. So 4 means sp3, sp3 tetrahedral. So shape is also tetrahedral. Why? Why shape is also tetrahedral? Because we have 4 bond pairs. We have 3 bond pairs, right? Sorry, 4 bond pairs. That's where the shape is also tetrahedral. Okay, clear? Now let's do the next question. Here, okay, property and shape. Property and shape. We have to match the molecules and species with respect to property and shape. So here we can apply the concept of MOT as well as Vesper theory. Okay, MOT and Vesper, both concepts we are going to apply in this question. So see, SO2Cl2. If we see SO2Cl2, so A option SO2Cl2. So have valence electron on central atom. Central atom is sulfur. Least in number, maximum valency. So 6. 2 monovalent chlorine. So 6 plus 2, 8. So 8 by 2, which is equal to 4. 4 means sp3 and geometry is tetrahedral. So we have how many bonds? SO2Cl2, right? SO2Cl2. So we can say SO2Cl2. So we have 4. The 4 basically we can say that 4 sigma bonds are there. So we can say tetrahedral can be correct option. Yeah, tetrahedral can be correct option. So A ko we can match with 3. Now then we have B, NO. We have B, that is the NO. NO diatomic. It's a diatomic. It means here we have to apply the concept of MOT. So let's write down the configuration of NO. So see, NO hai. So how many electrons? Nitrogen 7 electrons and oxygen total electrons 8 electrons, which is equal to 15 electrons. Okay. And now when we write down the configuration, so this is going to be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, right? Then we have pi 2px2, pi 2py2, then sigma 2pz2, and then pi star 2px1, right? So here this orbital contains only one electron, right? So we have unpaired electron over here. So for unpaired electron, NO co we can say that this is going to be the paramagnetic. This is going to be paramagnetic due to the presence of unpaired electron. And what are paramagnetic substances? Those substances which are weakly attracted by magnetic field. Those are known as a paramagnetic substance. So B is going to be paramagnetic. It means first. Then we have C, NO2 minus. So let's check for C. Let's check for C, NO2 minus. So let's find out the hybridization. Half 5 plus 1. Why 1? Because 1 negative charge and oxygen is divalent. So it is 3 and this is sp2. sp2 means geometry is trigonal planar, but we have this one now. This is O minus, right? We have O minus. Okay, so this is going to be the, okay, if I'm going to say this NO2 minus 1, NO2 minus 1, okay. So see what we can say about this. sp2 hoga, it can be sp2, but for sp2 we should be having trigonal planar, right? Trigonal planar, but it is going to be bent due to the presence of lone pair. So the shape is not trigonal planar, it is going to be bent. It is going to be the bent. Shape is going to be bent, right? So bent option is not there. It means we have to check whether it is diamagnetic or not. Whether it is diamagnetic or not. Okay? Whether it is diamagnetic or not. So let's do it. So see, if I say we have N double bond O, N double bond O. So 1, 2, 3, 4. The oxygen, we can form the coordinate bond, and we have 1, 2, 3, 4, 5, and we can say one negative charge, na? And due to the presence of one negative charge, we can put one electron, right? Due to the presence of one negative charge, we can put one electron, right? Or we can also write in that way, N double bond O, and this is single bond, and here we can put one extra electron to see 1, 2, 3, 4, 5, 6. 6, right? And due to one negative charge, I am writing one electron over here. ठीक है? और nitrogen, how many electrons in nitrogen? 5. So we can say 1, 2, 3, 4, 5. So basically all electrons are paired, right? All electrons are paired. See, all electrons are paired. So we can say NO2 minus can be diamagnetic. It is diamagnetic. So NO2 minus ko we can match with option number 2. That's a diamagnetic. Now let's talk about D. D, I3 minus. So I3 minus half. Central atom is iodine. Valence electron in iodine 7. Plus then 2 monovalent, because one iodine co we are taking as a central atom. So other two iodine, they are going to be surrounding atoms. So 2 plus 1 negative charge. So that is going to be 10 by 2, 5 sp3d. But we have only 2 bond pair plus 3 lone pair. So lone pair occupies equatorial position. Equatorial position. So we have I and this is going to be I. Understood? I, this one. Clarity. Is it clear? So we can say the shape is going to be the linear. So linear means fourth. So now let's check the option. SO2Cl2A option 3. Then we have B option first, C option second, and D option fourth. So option B is the correct option. Okay. Now let's do the next question. So what is the next question? Next question is, given below are two statements. One is labeled as assertion and other is labeled as reason R. So let's check. Assertion A, NH3 and NF3 molecule have pyramidal shape with a lone pair of electrons on nitrogen atom. The resultant dipole moment of ammonia is greater than that of NF3. Here we have to apply the concept of Vesper plus dipole moment. Vesper plus dipole moment. So see, if I talk about NH3 and NF3, so hybridization is sp3, sp3, but we have 3 bond pair plus 1 lone pair in both the cases. 3 bond pairs and 1 lone pair. So if I am going to write down the correct shape, so that is going to be H, 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 pyramidal shape. Here N, F, 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 and this. Now it says molecule have pyramidal shape. True. With a lone pair of electrons on nitrogen atom. True. The resultant dipole moment of NH3 is greater than that of NF3. Now we have to check the dipole moment. So see, if I want to check the dipole moment, so how to check this? See, nitrogen is more electronegative than hydrogen. So dipole moment is towards nitrogen. Here, nitrogen side we have the dipole moment, so the resultant dipole is in this direction. Understood? Resultant dipole is in this direction. Okay, let me redraw this and then we can discuss. So H, 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 and we have lone pair. Okay, so we can write the structure in that way. So see, here dipole moment is towards nitrogen, here dipole moment is towards nitrogen, and net dipole moment is towards here. So this is mu net 1. Now for next this bond, nitrogen hydrogen, dipole moment is towards nitrogen, and here dipole moment is towards lone pair, right? Nitrogen, right? It is towards lone pair. So the resultant dipole is going to be over here. So see, ऐसे होगा ना, like this. Resultant dipole moment is this. So mu net 2 is this, and mu net 1 and mu net 2 dipole moment, can we say that this is going to be in this direction, right? It is going to be in this direction. It is going to be in this direction. Clear or not? Okay. So it means here dipole moment is not equal to 0. But in the similar way, if we talk about NF3 molecule, as fluorine is more electronegative, so dipole moment is towards fluorine side, and here dipole moment is towards fluorine side. So mu net 1 is over here, mu net 1 is over here. Now check for this. Here Dipole moment is towards fluorine side, and here dipole moment is towards lone pair side. If we have the atom and the lone pair, then the dipole moment is towards that uh, element which is more electronegative. Or if the element is not there, bond pair is not there, then the dipole moment is towards lone pair. So we have dipole moment is over here, right? Can we write this? Mu net 2. So you can see mu net 1, right, is in opposite direction, is in opposite direction with respect to mu net 2. But for mu net 2, we have one nitrogen fluorine and one nitrogen lone pair, mu net 2. And for mu net 1, we have one nitrogen fluorine, two nitrogen fluorine. We have what? Two nitrogen fluorine. So that's why lone pair, dipole moment cannot cancel. Dipole moment cannot cancel, but obviously NF3 dipole moment is less than in comparison to ammonia. So this statement is true because in NH3 all dipole moments are in same direction. All dipole moments are in same direction. So that's why dipole moment of NH3 is greater than the dipole moment of NF3. Next, in NH3 the orbital dipole due to lone pair is in the same direction as that of resultant dipole moment of NH bond. It is true. Fluorine is the most electronegative element. Yeah, it is also true. So basically what we can write, both assertion and reason are true, and R is the correct explanation of assertion A. Right. That's it. Now let's do the next question. Number of sigma and pi bonds present in ethylene molecule is respectively. So for that you should know the covalent bond structure, right? Covalent bond structure of ethylene molecule. So what is ethylene molecule? Ethylene molecule is ethene. So we have carbon-carbon double bond and two carbon atoms. Rest bond is with hydrogen atom. Now let's calculate the sigma bonds. So we have 1 sigma bond, 2 sigma bond and 3 sigma bonds. Here 4 and 5. So total 5 sigma bonds, and this is 1 pi bond. So 5 sigma and 1 pi bond. So option B is the correct answer. Okay. So if we have one bond in between two atoms, that is going to be sigma. If we have two bonds in between two atoms, one is going to be sigma, another one is going to be pi. If we have three bonds in between two atoms, so one is sigma, other two, they are going to be pi. And if we have four bonds in between two atoms, then one sigma, two pi, and another one delta bond. Okay, so in that way, we can find out the correct number of bonds. Okay, now let's do the next question. The correct statement about hydrogen bonding is R. So this topic is hydrogen bonding, right? This topic or this question is from hydrogen bonding topic. So let's do the question. Let's read the statement A. Hydrogen bonding exists when hydrogen is covalently bonded to the highly electronegative atom. Yeah, it's true. Why it is true? Why it is true? So see, hydrogen bonding, hydrogen bond can be formed in between hydrogen and electronegative atoms. Electronegative atoms such as oxygen, nitrogen, and halogens. Halogen, maybe we have fluorine, oxygen, nitrogen, and fluorine. So the point is that if this hydrogen is bonded to more electronegative atom, that is fluorine, right? So what happens? As fluorine is more electronegative, right, or it is the most electronegative element in the periodic table, so the electrons are more closer to fluorine side, right? Electrons are more closer to fluorine side. So due to which this hydrogen, it becomes electron deficient and it carries partial positive charge, and fluorine delta negative. Due to the development of partial positive charge on this hydrogen, it pulls electron from this one, from this fluorine, right? So that's why we have the concept of the hydrogen bonding. That's why we have the concept of hydrogen bonding. And it is more strong if the hydrogen is attached to more electronegative atom. And electronegativity order is fluorine, oxygen, and nitrogen. Okay, so this is true. Intermolecular hydrogen bonding is present in orthonitrophenol. No, this is false. What is orthonitrophenol? So this is phenol, and at ortho position we have to put nitro group. So we have hydrogen bonding but within the molecule. So we do not have intermolecular. Inter means between two molecules. So we do not have intermolecular hydrogen bonding. We have intramolecular hydrogen bonding. We have what? Intramolecular hydrogen bonding. Now, intramolecular hydrogen bonding is present in HF? No. Here we have intermolecular hydrogen bonding. Here we have intermolecular. See, in between two molecules we have hydrogen bonding. Right? So we have intermolecular hydrogen bonding, not intramolecular hydrogen bonding. Now next, the magnitude of hydrogen bonding depends on the physical state of compound. It is true. It is true. Hydrogen bonding is more in solid state and least in gaseous state. So solid, then liquid, then in gaseous state. Right? Because in solid state there is no, or we can say very less motion of the particles. Right? So hydrogen bonding is strong in that case. Hydrogen bonding has powerful effect on the structure and properties of the compound. True, true. Structure and properties. Right. If we have the hydrogen bonding, then boiling point increases. Solubility in water increases. Right. So these are the powerful effects. So this is also true. So now question is choose the correct answer from the options given below. So we have option A true, D true, and E true. So it means option C is the correct answer. Okay. Now let's do the next question. The number of species from the following that have pyramidal geometry around the atom. Acha, pyramidal is not geometry, basically pyramidal shape, right? So it means you have to find out the shape. So how to find out the shape? Obviously, we have to find out the hybridization. So see, we have S2O3 2 minus. So देखो here ना S2 है, two sulfur atoms है. So what you need to do, just try to write down the structure first. And how to write down the structure? You have to form the symmetrical structure. How? See, sulfur can form maximum 6 covalent bonds. 6 covalent bonds. Why? Because valence electrons in sulfur, they are equal to 6, and oxygen can form maximum 2 covalent bonds. Sulfur forms maximum 6 covalent bonds and oxygen forms maximum 2 covalent bonds. So we are going to do in that way. So 2 sulfur, so 2 double bond oxygen, right? Double bond oxygen. Then we have O minus, O minus. Clear? We have, acha now, no. What we are going to do, this is S2O3 2 minus, na? S2O3 2 minus. No, here this is thiosulfate. So what we are going to do to S? Double bond S, because this is thiosulfate. Sulfur bond is there. Then we have double bond, then O minus, and then O minus. So how many sigma bonds? 1, 2, 3, 4. So 4 sigma bonds means sp3. sp3 means tetrahedral because all are bonds, right? We do not have any lone pair. So for pyramidal, we should be having 3 bond pair plus 1 lone pair. So S2O3, no. Let's check for SO4 2 minus. So same S, double bond O, O minus, because sulfur can form 6 bonds now. So again we have 4 bond pair, so no. Let's check for SO3 2 minus. SO3 2 minus S, double bond O minus. Okay, now we have one lone pair. Or we can also calculate hybridization in order to check the answer. To have 6 valence electrons, 2 magnitude of negative charge. So this is going to be 4. So sp3 plus 1 lone pair. So yes, it is going to be pyramidal. So this is correct. Now S2O7 2 minus. Let's draw symmetrical structure. S2O7 2 minus. S form double bond O. डबल बॉन्ड O, डबल बॉन्ड O. ठीक है. Now 2 oxygen, negative, negative. Both sulfur forms 5 bonds, right? Now we have one bond left. So one bond left is with the oxygen, like this. So this is also sp3 hybridized, and this sulfur is also sp3 hybridized. You can calculate the number of sigma bonds. So it means tetrahedral, not pyramidal. So only one species, right? One species have the pyramidal geometry. The answer is D. Now let's do the next question. Which one of the following molecules has maximum dipole moment? So dipole moment. So in order to find out the dipole moment, what is the idea or significance of dipole moment? So dipole moment is used to find out polarity or ionic character in covalent compounds. But before checking with the dipole moment, we have to find out the correct geometry. It is mandatory. Geometry. So geometry we are going to find out via steric number. So you can calculate iska geometry. Steric number is 4. Hybridization is sp3. Iska 5 plus 3, 6, 7, 8. 8 divided by 2, 4. 4 again sp3. This is sp3 plus 1 lone pair. And this is what? pf5. 5 plus 5, 10. So sp3d plus 0 lone pair. In NF3 also 1 lone pair. sp3 0 lone pair. So now let's find out for CH4. So CH4 is this H, 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 H. So see, out of carbon and hydrogen, carbon is more electronegative. So dipole is towards carbon. So now for these two, dipole, net dipole moment is towards this side. Now check for this. Dipole moment is towards carbon, and here dipole moment is towards different side. So if blue one is the mu net 2 and red one is the mu net 1, so we can say that mu net 1 is minus of mu net 2 and total mu net is equal to mu net 1 plus mu net 2, which makes total dipole moment or net dipole moment equal to 0. So here it is 0. Dipole moment is 0. Let's check for PF5. D, PF5. See, trigonal planar. So fluorine is more electronegative. So here we have. So this cancels out, right? This is suppose mu net 1 and this is mu 2. So mu net 1 and mu net 2 cancels. Now let's check for this one. Suppose this is mu 3 and this is mu 4. So mu 3 is equal to minus of mu 4. So total mu net for this molecule is equal to 0. Okay. Now we have to check for NH3 and NF3. So just in this video we have discussed that ammonia dipole moment is more because lone pairs and the total dipole moment, they are in the same direction, right? So that's why option C is the correct answer. Okay, option C is the correct answer. Now let's do the next question. Okay, this is the question of MOT, molecular orbital theory. So what is the question? A pi bonding MO has lower electron density above and below the internuclear axis. It means we have to form pi bond, and pi bonding MO, yani pi BMO. It means we have to do what? Positive overlapping. So let's take, let's understand this by taking the example of PP overlapping. So we have positive, negative, then we have positive and negative. So what happens? Positive overlaps with positive and negative overlaps with the negative. So on positive overlapping, we have one positive, the positive lobe, it becomes bigger. Similarly, negative lobe, it becomes bigger. So we have one node over here, right? So it says a pi bonding molecular orbital has lower electron density above and below internuclear axis. No, this is INA, na? What is internuclear axis? Through which bond is going to form. So we have more electron density, not less. So here we should be having more electron density. So this statement is false. Next, the pi star anti-bonding molecular orbital has a node between the nuclei. Yeah, it is true. So just try to understand this. If I want to form pi star anti-bonding, na, so we have to do the negative overlapping. For pi ABMO, we have to do what? Negative overlapping. So if I want to do negative overlapping, so it means positive, एक minute, positive, negative, this is P and this is negative, positive. So positive should overlap with negative and negative should overlap this positive. So what happens? So we are going to have this positive, negative, negative, positive. Right? So we have a node. See, we have nodes. We have two nodes over here. So yes, this is the correct statement. This is true. So we can say statement 1 is false, but statement 2 is true. So option D is the correct answer. Now let's do the next question. Select the compound from the following that will show intramolecular hydrogen bonding. Intramolecular hydrogen bonding means within same molecule. So obviously that is going to be the orthonitrophenol, right? Orthonitrophenol. So we have hydrogen bonding. So that's the answer. H2O, we have inter. In alcohol, we have inter. And in NH3, we have intermolecular hydrogen bonding, not intramolecular hydrogen bonding. Now, let's do next question. pH3 has lower boiling point than NH3. See, boiling point is directly proportional to molar mass. So if we have more mass, then the boiling point is more. So if we talk about NH3 and pH3, what is the expected boiling point? pH3 should have more boiling point in comparison to ammonia. But pH3 has lower boiling point than ammonia. Yes, this is true. But why? Because in ammonia, we have hydrogen bonding, intermolecular hydrogen bonding. So due to intermolecular hydrogen bonding, we can say molar mass increases, right? Intermolecular hydrogen bonding hai. First, we have only 1 mole of NH3. Now we have 2 mole of ammonia associated together. So mass is going to be more. And if mass is going to be the more, then boiling point is going to be more. So this is true. Next, in liquid state, NH3 molecules are associated through van der Waals forces. Nahi, nahi. In liquid state, it exists. They are associated through hydrogen bonding. But pH3 molecules are associated through van der Waals. Yes, we can say pH3 molecules, they can be associated through van der Waals force. So if we have the non-polar molecule or if the polarity is less, then we can say that van der Waals force can be present. Otherwise, if we have a polar molecule, then dipole-dipole interaction can be there. Okay, so reason is false. So A is correct and R is not correct. So option C is the correct answer. Now let's do the next question. Arrange the bonds in order of increasing ionic character in the molecules. See, here we have different molecules. See, metal bond is in between metal and non-metal, then potassium, then oxygen. So see, if I want to find out covalent character in ionic bonds, covalent character in ionic bonds, covalent character in ionic bonds. So that is as per Fajan's rule. Fajan's rule. And in Fajan's rule, if the polarizing power is more, then covalent character is more. And if covalent character is more, so ionic character is less. Ionic character is less. So here can we apply Fajan's rule? Because we have to find out covalent character in ionic bonds. Right? Covalent character in ionic bonds. Here we cannot apply Fajan's rule. Why? Because in order to apply, in order to do the comparison ना, we should be having similar type of ions. जैसे LiF can be compared with NaF. Here LiF है और K2O है, so we cannot compare in between मतलब we cannot compare LiF with K2O on the basis of Fajans rule, but we can compare LiF and NaF ionic character or covalent character on the basis of Fajans rule. So here how to do this? See, if we see the molecules N2, here electronegativity difference is equal to 0. So this is the pure covalent molecule. So here covalent character is more. So it means ionic character is less, right? Least ionic character. So from this option A can be correct and option D can be correct. Now we have to check which one has more ionic character, LiF or K2O. So see, LiF, obviously electronegativity difference is more in comparison to K2O. Electronegativity difference is less. Why? Because see, lithium and fluorine, then we have potassium, and then we have oxygen. So down the group electronegativity decreases, na? Down the group electronegativity decreases, right? So we can say if we have more electronegativity difference, then the bond is going to be more polar. So LiF more polar than K2O. Now we have to check for ClF3 and SO2. Now we have to check for ClF3 and SO2. So ClF3, let's check, and SO2. So SO2 is this, and then we have two lone pair. Then ClF3 structure is this, right? T shape, and we have lone pair like this. So how to do this? We have to check the dipole moment. Here we have to check the dipole moment. How? Sulfur and oxygen. Electronegativity, oxygen is more electronegative, so dipole moment is towards oxygen, and here net dipole moment is towards here, right? It is towards here. Now out of sulfur and lone pair, dipole moment is towards lone pair side, right? And here, so we can say that mu net 1 and mu net 2, they are in opposite direction. Obviously they cannot cancel, but they are in opposite direction. So dipole moment is less. But if we talk about this one, so here the dipole moment cancel out, and here we have dipole moment towards fluorine side, and here dipole moment towards right hand side, right? So here also ये तो cancel है. This is mu1 and mu2. So mu1 is minus of mu2, so due to which it is equal to 0. ठीक है. Then we have ये mu3, and this is going to be the mu net 1. So mu3 is also with respect to mu net, मतलब minus of mu net 1. Opposite direction. अब how to check? How to check? Because in both lone pair due to dipole moment due to the lone pair and dipole moment due to the bond, right? That is in opposite direction. So now how to check? So for that we have to check the electronegativity of the atom. So as fluorine is more electronegative, so it has more tendency to attract the electron towards itself, and due to the high electronegativity of fluorine, ionic character is going to be more in case of ClF3. So here option A is going to be the correct answer. N2 least, SO2, then ClF3, K2, and then LiF, right? So this is going to be the correct answer. Okay. Now let's do the next question. Which of the following is least ionic? A. Cobalt chloride, B. KCl, C. Barium chloride, D. AgCl. So which of the following is least ionic? So how to do this question? To see, we know that left to right, or moving left to right, metallic character decreases, right? Metallic character decreases. Metallic character decreases. And Cl minus is same in all. Cl minus is same in all. So it means we have to find out the ionic character with respect to cation only. So if metallic character decreases, so we can say ionic character also decreases. Ionic character also decreases. So on left hand side we have two, cobalt and silver, right? Cobalt and silver. So we have scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, and below copper we have silver. Now we can have the question, okay, fine, left to right or moving left to right metallic character decreases, but on moving top to bottom metallic character increases, na? So out of cobalt and Ag, which one is going to have least ionic character? So in order to find out this, so we have to apply the Fajans rule. In the Fajans rule, we have one rule. What is that rule? The cation which has pseudo inert gas configuration, the cation which has pseudo inert gas configuration, right, has more polarizing power, and more polarizing power means more covalent character. More covalent character means least ionic. Least ionic. And what is pseudo inert gas configuration? This is NS2, NP6, and D10. So here, if we talk about Ag, so we have copper, below that we have silver, and then we have gold. Okay. So copper is what? Copper is 3D10 4s1. So Ag is 4D10 5s1, and gold is 5D10 6s1. So Ag is 4D10 5s1, and if I write Ag plus, so we have to remove electron from 5f, so this is going to be 4D10. And before 4D, we have electrons in 4s2, 4p6 and 4d10. So Ag plus, right? Ag plus in AgCl, it has pseudo inert gas configuration. So pseudo inert gas configuration, because what is inert gas? Inert gas configuration is Ns2Np6. So it is pseudo. Why? Because here we have electrons in D and D is also completely filled. So it has more polarizing power, right? So more covalent character. So that's it. So from this explanation, we can say that AgCl is least ionic, and why? What is the reason? What is the actual reason? That is the pseudo inert gas configuration. So we have applied Fajans rule over here, right? Which rule? Fajans rule. So we have certain rules now. We have 5 rules in this. Okay. Now let's do the next question. Aluminium chloride in acidified aqueous solution forms an ion having geometry. Oh, square, planar, octahedral, trigonal, bipyramidal, tetrahedral. So when you see this kind of questions now, though you have to understand some part of the coordination chemistry as well. See, we have aluminium chloride and it's a key aluminium chloride in acidified aqueous solution. Acidified aqueous solution. So what happens? So basically aluminum forms a complex. Aluminum forms aqua complex, and generally we have complex which exist in octahedral geometry. So we get this thing. Okay. Or we can also write AlH2O whole 6 and here we write Cl3. Okay. So octahedral. We have complexes which exist in octahedral geometry. Okay. Now, so answer is B for this question. Now let's do the next question. We have two statements, assertion A and reason R. So let's read assertion A. There is a considerable increase in covalent radius from nitrogen to phosphorus. However, from arsenic to bismuth, only a small increase in covalent radius is observed. True, right? We have discussed this. So let's write down this group 15. Group 15, how to write down? Naya, Purana, Asli, सब बिकेगा, right? So nitrogen we have 2s2 2p3, phosphorus we have 3s2 3p3, arsenic we have 4s2 4p3, this is we have 5s2 5p3, and this is we have 6s2 6p3. Now before 4s and 4p we have electrons in 3d, here we have electrons in 4d, and here we have electrons in 5d and also in 4f. Understood? So the point is that statement says कि from nitrogen to phosphorus there is a significant increase in the covalent radius. And why we are talking about covalent radius? Because nitrogen and phosphorus both are non-metals. However, from arsenic to bismuth only a small increase. Arsenic to bismuth only a small increase. Why? Because we have 4D and 4F, right? So they have poor shielding effect. right? So D and F have poor shielding effect. So due to poor shielding effect, Z effective increases, and if Z effective increases, effective nuclear charge increases, then valence electrons are more closer to the nucleus. So we do not have any significant change in the covalent radius in terms of magnitude. So yes, this is true. We can say this is true. So now reason, covalent and ionic radii in a particular oxidation state increases down the group. Yeah, this is true. Yeah, this is true. Ki, yes, this statement is also true. Ki like generally, if we talk about the size, if we talk about covalent radius, or we can say atomic size or ionic size, so on moving down the group, it increases. Why it increases? Because if number of shell increases, then distance between nucleus and outermost shell increases, and we can say radii increases. But that is not the correct explanation. Explanation is with respect to the shielding effect. Okay, so we can say both A and R are true, but R is not the correct explanation of assertion. So option C is going to be the correct answer. Okay, now let's do the next question. The difference in energy between the actual structure and the lowest energy resonance structure for the given compound, that is the resonance energy. That is the resonance energy. So see, just say if I talk about structure ozone, ozone is this, right? So we can form the resonating structure in that way. How? Ki this pi bond can move over here. So we can write O or either double bond O, right? But these two structures, right? Although these structures are equivalent resonating structures, but single structure does not represent the molecule completely. Which represents the molecule completely? Resonance hybrid. And resonance hybrid we are going to right in that way. ठीक है? So this is the मतलब for this structure we have certain energy, and as these structures are equivalent resonating structures, so equally stable means we can say equal energy. So there is energy of this structure, suppose 1 and 2, so any ka we have energy of this. So what is resonance energy? So it is the difference in energy. So resonance energy, difference in energy, like resonance hybrid, which is the third structure, minus energy of most stable structure. So here we have equivalent resonating structure, na? So all structures are equally stable, equal energy. So for any structure you can take the energy, right? So the difference is called the resonance energy. The difference is called the resonance energy. Okay, now let's do the next question. The number of POP bonds in H4P2O7, HPO3 whole thrice and P4O10 are respectively. So let's do this. देखो H4P2O7, right? So when we draw, if we have some oxy acid of phosphorus, so we have one P double bond O. One phosphorus should be bonded to oxygen by forming double bond. Then we have POH bond, and after that if still hydrogen is left, then we have to draw pH bond. That's the rule. Okay, so if we have H4P2O7, so H4P2O7 means P double bond O. We have to draw symmetrical structure, P double bond O. Now 4OH, so I am writing OH, OH. Here also OH, OH. So how many oxygen? 1, 2, 3, 4, 5, 6. So 6 oxygen, they are already involved in these structures. So we have left 1 oxygen. So this is OO. So in H4P2O7, we have 1. We have 1 POP bond. Right? We have 1 POP bond. See? POP. So we have 1 POP bond. Now we have HPO3 whole thrice, right? HPO3 whole thrice. So how to do this? So it is going to be cyclic one. So P double bond O, P double bond O, and HPO3 whole thrice है ना? So P double bond O. Okay, P double bond O. ठीक है. Now we have OH, right? OH, 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 and OH. So HPO3 मतलब we two है, so we have to form one oxygen ना, we have to form one oxygen. So one oxygen of this is this, for this oxygen is this, and for this oxygen is this, for this oxygen is this. So we have how many POP bonds? So obviously we have three POP bonds, 1 2 and 3. So here we have 3. Now next P4O10. So again same, we have to draw similarly P4O10. So double bond O, double bond O, double bond O, double bond O, P4O10. So there is no, what we can say, there is no hydrogen, ठीक है. So P4O10 है, so 4 oxygen are already in the structure, then 5 6 7 8, right? Each phosphorus can form 5 bonds. So if each phosphorus can form 5 bonds, so here we have only 4 bonds. So now one bond like this, and then another bond like this. So how many POP bonds we have? So how many POP bonds we have? 1 2 3 4 5 and 6, right? 6, total 6. So what is the answer? 1 3 and 6. So option A is the correct answer. Okay, now let's do the next question. So we have certain statements, and we have to choose the correct number of statements, right? So first is NF3 molecule has trigonal planar structure, NF3. So in order to find out the structure, we have to find out hybridization. So NF3 static number half, nitrogen valence electrons 5, 3 monovalent, so 4. sp3, so sp3 cannot have trigonal planar structure, so we have N, F, F, F and one lone pair. So this is the pyramidal structure. Pyramidal structure. So it means that statement is false. Now next, bond length of N2 is shorter than O2. So nitrogen we have triple bond and oxygen we have double bond. Right? Nitrogen we have triple bond and oxygen we have double bond. So basically on moving left to right, size decreases, right, due to the increase in effective nuclear charge. But here we have to take care of the total number of bonds that present in between two atoms. So here we have triple bond now, so obviously triple bond is shorter than the double bond. So this is true, this we can say this is true, so B is true. Okay, now isoelectronic molecules or ions have identical bond order. Yes, this is also true. Isoelectronic species or ions, they have identical bond order. जैसे for example, if I write for nitrogen we have 14 electrons na total. So how to write the configuration? Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Then we have pi 2px2, pi 2py2, then sigma 2pz2. How many electrons? 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All done. Now how to calculate bond order? Bond order is going to be half number of electrons in bonding molecular orbital minus number of electrons in anti-bonding molecular orbital. So half. So here 2, 4, 5, 6, 7, 8, 9, 10. 10, then anti-bonding 4. So it is going to be 3. Similarly, we have CO, carbon is 7 and this is 8. So that is also 14 electrons. So when we write down the electronic configuration for this one, so this is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Now what is the difference in between carbon monoxide carbonyl electronic configuration and nitrogen configuration? Like we have to write sigma 2pz first. So here sigma 2pz2, pi 2px2 and pi 2p by 2. So same cheese na, the bond order is equal to half 10 minus 4, which is equal to 3. So this is always true. Isoelectronic species, they are going to have same bond order. So this is correct. Now next, dipole moment of H2S is higher than that of water molecule, right? H2S. So H2S hai. So H2S dipole moment is higher than that of water molecule. No, it cannot be true. Why? Because oxygen है ना, oxygen. So oxygen is more electronegative, so it has more tendency to pull the electron towards itself in comparison to sulfur. So that's why dipole moment cannot be greater. Dipole moment of H2S cannot be higher. So this statement is actually false. So out of all the statements, what are the correct statements? B and C, they are the correct statements. Right? Now let's do the next question. Next question. SO2 and water both possess V-shaped structure. Yeah, that's true. SO2, water ka to we know that water OH2, sp3 hybridized plus 2 lone pair. So 2 lone pair hai, so we can write down the shape of water as this. If we talk about SO2, so SO2 is going to be half 6. 6, so that is 3. 3 is sp2. So here we write like S double bond O, and we have one lone pair, right? One lone pair. So that is also a V shape, na? That is also a V shape. So that's true. Now, the angle of SO2 is less than that of water. No, less क्यों होगा? Why? Because sp3 है, sp3 less S character, less percentage S character. So if we have less percentage S character, then less bond angle, na? Less bond angle. So obviously bond angle of SO2 must be high. It should be high. So this statement is false. So it means statement 1 is true and statement 2 is incorrect. Okay, so option C is going to be the correct answer. Okay, now let's do the next question. In which of the following process the bond order increases and paramagnetic character changes to diamagnetic? So see, for the paramagnetic one, we should be having unpaired electron, and for the diamagnetic one, we should be having a paired electron. Okay, and how to calculate bond order? Half number of electrons in bonding molecular orbital minus number of electrons in anti-bonding molecular orbital. So this is how we can find out the bond order. So by using this concept, let's find out the correct answer. So see, we have O2. So O2 may we have 16 electrons. So on writing the electronic configuration, we write 1 sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Now we write sigma 2pz2. Then we have this rule. If the electrons are more than 14 electrons, now the first electron goes to sigma 2pz and then pi 2px. Then pi 2p by 2 due to the sp mixing concept. 2p2, so we have 14, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now we write pi star 2px1 and pi star 2p by 1. Okay. So bond order we have to find out. Okay. And paramagnetic character changes to diamagnetic. So here it is paramagnetic. Okay. Here it is paramagnetic. Right. Perfect. Now, if I write O2 2 minus, so for O2 2 minus, we are going to fill electrons over here, right? So it is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, right? Pi 2px2, then pi 2py2, and then pi star 2px2 and pi star 2py2, because we have to add 2 extra electrons. So, okay, one thing is clear कि paramagnetic character changes to diamagnetic, because here we have unpaired electrons and here we do not have any unpaired electron. Up now we have to find out the bond order. So bond order for O2, it should be 2. But let's use the formula to calculate half. So 2, 4, 5, 6, 7, 8, 9, 10. 10. Now rest 2, 4, 5, 6. 6. So that is 2. Now calculate bond order of O2 minus. So bond order of O2 minus half. So we have 10 minus 8. So that is equal to 1. Right? That is equal to 1 na? Because we have to add 2 anti-bonding में ना. So see, 2, 4, 5, 6, 7, 8, 9, 10. Right? And then 2, 4, 5, 6, 7, 8. ठीक है, तो 2 by 2 that is equal to 1, but bond order decreases, so this cannot be correct. So on the similar way, you have to write down the configuration. And once you write down the configuration, you have to calculate bond order and you have to calculate the magnetic nature, and then you can find out the correct answer. I'm marking the correct answer for you, so you can try it at home and then solve it. So correct answer is C. So in the C1, what happens? Paramagnetic character changes to the diamagnetic one. Now let's do the next question. ClF5 at room temperature is a colorless liquid with square pyramidal geometry, colorless gas with square pyramidal geometry, colorless gas with trigonal bipyramidal geometry, and colorless liquid with trigonal bipyramidal geometry. It means what we are going to find out, we need to find out the geometry of ClF5, right? So ClF5. So let's find out the geometry of ClF5. So steric number half, 7 plus 5, that is 12 by 2, which is equal to 6. So which is sp3d2, octahedral, having 5 bond pairs plus 1 lone pair. So 5 bond pair and 1 lone pair, it means it is square pyramidal. It is what? Square pyramidal geometry. And 1 is going to be the lone pair, right? So it is confirmed this is square pyramidal geometry. And now ClF5 at room temperature, it is going to be the liquid. It is going to be the liquid. So answer is A. Now let's do the next question. The bond order and magnetic property of acetylide ion are same as that of acetylide. It is from acetylene. What is acetylene? Acetylene is this HC triple bond CH. So an ion is, it means you have to remove hydrogen. So we get HC triple bond C minus. So how to solve this question now? Just calculate the total number of electrons in that. So if I'm going to calculate total number of electrons in acetylide ion, so that is going to be carbon how many? 6. So 6 into 2, hydrogen 1 electron. Hydrogen 1 electron, right? 1 electron and 1 negative charge, so 1 extra electron. So we can say that 12, 13, 14. So we have 14 electrons. So easiest way to do this question is to calculate the total number of electrons present in option A, B, C and D. So O2 plus O2 16, 16 minus 1, total 15 electrons. O2 16, 16 plus 1, total 17 electrons. Here N2, N2 14, 14 minus 1, 13 electrons, and in NO plus we have 7 plus 8 minus 1, so it means 14 electrons. So we have already discussed that isoelectronic species, right, they have the same bond order, so it means NO plus is going to be the answer. There is no need to write down the configuration in terms of sigma 1s2 sigma star 1s2. No, there is no need to do that, right? So just find out the total number of electrons and take the correct answer. Okay, now let's do the next question. Match list 1 with list 2. Okay, so we have HCO positive, acetylide anion, NH4 positive, ClO2 minus, and we have to match with respect to geometry and the shape. Okay, so let's do it. So this, देखो, see HCO positive, you have to find out the steric number, right? So I'm going to do only for 2 options, and then for the rest of the option you can do on your own. So HCO positive, oxygen, valence electron 6, monovalent atoms 3 because 3 hydrogen, but we have one positive charge, so minus 1. So it is going to be 4. It means it is sp3, right? It is sp3. sp3 means 3 bond pair plus 1 lone pair. Okay, so we can say this is going to be the pyramidal. This is going to be the pyramidal. Pyramidal, so A option can be matched with option number 3. Acetylide ion, we have already discussed above. So CH triple bond C minus. So how many sigma bonds for this carbon? For this carbon, how many sigma bonds? 2. 1 and 1 sigma bond is with the hydrogen. So 2 sigma bonds, sp hybridization. sp hybridization means linear. So for acetylide ion, it is second. Okay. So in this similar way, you can check for other options. And if I mark the correct answer, so this is going to be A3, B second. So option B is the correct answer. Okay. So similarly, you have to find out the geometry and shape. Okay. Okay. Now the compound which does not exist is, So the compound which does not exist is, so basically C. Answer is NaO2, right? Because naturally sodium oxide which exists in nature, that is Na2O. It exists, right? It exists. But NaO2 does not exist. NaO2 means Na plus and O2 minus, right? So O2 minus is superoxide. So superoxide of NaO2 does not exist, right? Superoxide does not exist. Does not exist. ठीक है? So on moving down the group now, then superoxide tendency is going to increase. So first we have oxide, then we have peroxide, right? And then we can have the superoxide. But sodium ka we do not have superoxide, we only have the oxide. And now let's see कि BeH2 exists. Yes, BeH2 exists. How? See, BeH2. Hydrogen, helium, lithium, beryllium. The atomic number 4. So beryllium is basically 2s2. Okay, beryllium is 2s2 and it can form two bonds. So see, if we have H, Be, and this is H. So beryllium only has 4 electrons now. 1, 2, 3, 4. Yes, if we write one more beryllium, so H, H. So 4 electrons. So what happens? What happens? So we have a kind of bridge bonding. So we have a bridge bonding over here. We have bridge bonding, right? So when we have bridge bonding in case of BeH2 ना, so octet gets temporarily complete, right? तो octet temporarily way में complete हो जाता है, ये समझना है इसमें. So अब यहाँ पे क्या हो जाता है? If the octet is मतलब due to the bridge bonding, either we can have the bridge bonding, and if we have bridge bonding, so octet temporarily complete. ठीक है? So that's why we can say BeH2 can exist, right? If we say PbEt4, so Pb है तो lead है ना, lead. So generally तो lead exists in +2 oxidation state, but right we have Pb. So Pbe2 it can form 4 bonds, right? It can form 4 bonds. Lead lies in which group? Chemistry sir gave Sankey problem. So it can form 4 bonds. So it is possible. It can form C2H5. Here it can form C2H5 bond, C2H5 and C2H5. ठीक है? It can exist. Whether it is stable or not, that's a different part, but it can exist. NH4 2 BeF4 minus. So this is what? 2NH4 positive and we have BeF4 minus. BeF4 minus. ठीक है? So अब BeF4 minus है. So what we can say? Can it exist? So see, beryllium is what? 2s2. ठीक है? But 2p is empty. So 2s 2 electron and 2p no electron. So what happens? One electron of 2s, right? It is promoted to 2p. It is promoted to 2p. Right? It is promoted to 2p. Okay? Okay? So in that way we can say ki it can form bond. In that way we can say it can form bond, right? Because what happens? BeF4 further gives BeF3 and we can say F minus. Okay, is it clear? ठीक है कि BeF4 2 minus होगा, it should be 2 minus. So if it should be 2 minus, so we can say one is with fluorine, one bond is with fluorine, then one bond is with F minus and one bond is with F minus. So for F minus now there is no need to have the electrons in the beryllium orbital. So there is no need for that, right? So it means it can exist. So answer is going to be NaO2. It does not exist. Up see, match list 1 with the list 2. So we have N2O4, NO2, N2O5 and N2O. So we have to find out the types of bond, right, that we have in this structure. So it's very easy. So see, if I want to form NO2 structure now, so this is going to be this. Because nitrogen can form 3 bonds. Nitrogen can form 3 bonds. So maximum 3 bonds hai. So if I write N2O4, so N2O4 is double bond though. One is the coordinate bond, right? Then one this one coordinate bond and one double bond. So nitrogen can form three bonds, and then we have one lone pair on nitrogen, and one lone pair on nitrogen can form coordinate bond, right? It can form coordinate bond. So this is the N2O4, this is the NO2. Now if we have N2O5, so how to write? Just put one oxygen in between two nitrogen, right? So here we can say, in that way we can form N2O5 structure, N double bond O N coordinate bond and then double bond O. So that is the N2O5 structure. Then we have N2O structure. So N2O structure may we can write in that way, N double bond N, and then we can have the coordinate bond. हो सकता है, this is possible, right? N double bond N, and then we can have this, or we can say N triple bond N, and then we can have the coordinate bond. So we can also have the resonating structure for this one. We can have the resonating structure for this one. Okay, we can have it. So if we match with the options now, if we match with the option, then option number B is going to be the correct answer. So A का answer is third. N2O4 में obviously we have one, है ना? So A is third. NO2 answer is N double bond O, one N double bond O. Very good. N2O5 में we have one NON bond. Yes, one NON bond. So that is the second, and then it is 4. Okay, so it's just we have to write down the correct structure by using the octet rule. Okay, now let's do the next question. Oxygen bond length in H2O2 is X. H2O2, right? Oxygen bond length is X. Is X? X. Then the oxygen bond length in this. Okay. Okay. So if I want to check the oxygen bond length, to see what happens. Fluorine is more electronegative, so electrons are more closer to this side, and electrons are more closer to this side. So it means here OF bond is longer. So if OF bond is longer, so we can say oxygen bond is going to be the shorter, right? Shorter. Okay. Up now here, if I say this one, here oxygen is more electronegative, so electrons are more closer to oxygen side. So OH bond is right. तो OH bond यहाँ पे OO क्या हो जाएगा? This OO bond, right? If this is OF bond is longer, then OO is shorter. So here we can say that keep oxygen. If this is we can say this is longer, or we can say this is again shorter. But if I want to do the comparison, so OO bond is actually in H2O2, it is longer. It is longer than OO bond in O2F2. And OH bond in H2O2, right, is shorter than that of OF bond in O2F2, right? So basically, if I want to do the comparison, so we have to check the electronegativity difference. The one which has high electronegativity difference, that is going to be longer. The one which has high electronegativity difference, that is going to be the longer, and the one which have less electronegativity difference, that is going to be the shorter. So if I am going to apply this concept, then answer is going to be the B. Answer is going to be the B. That's it. Now let's do the next question. According to MO3, the bond order for O2 minus CO and NO plus respectively are. So what you need to do? Obviously you have to write the electronic configuration in terms of sigma 1s2 and sigma star 1s2, right? So when you write this, you get the answer equal to 1, option number A. CO mein what is the difference? First you have to fill electron in sigma 2pz, and then you will write electron in type pi 2px and then pi 2py. Pi 2py. Okay. Now let's do the next question. Decreasing order of hydrogen bonding in following forms of water. So hydrogen bonding is state dependent. So it is more in solid state, then in liquid state, and then in gaseous state. So on the basis of that, we can say answer is going to be B, A, and C. B, A, and C. It means in ice we have more hydrogen bonding than water in liquid state, and then impure water. Okay. Now let's do the next question. Number of molecules from the following which are exceptions to octet rule. It means where central atom does not have 8 electrons, right, in outermost shell. So they are going to be exceptions to octet rule and still they are stable. Okay. So here we have answer NO2. NO2 is odd electron species. How? N double bond O, lone pair, and we have only one electron. 5 electrons are present on nitrogen. Now 1, 2, 3, 4, and this is 5. Because for the coordinate bond, we should be having 2 electrons, right? So if I count the total number of electrons around nitrogen, that is going to be 7 electrons. But still it is stable. If I say H2SO4, so that's the hypervalent. It means more than 8 electrons. So see, S double bond O, OH, OH. Now count the electrons. 2 bonds, 4 electrons, 2 bonds, 4 electrons, 1 bond, 2 electron, 1 bond, 2 electron. It means greater than 8 electrons. Right? BF3, stable. But we can say this is hypovalent species. Hypovalent species means less than 8 electrons. See, F, 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 F. So 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. So less than 8 electrons. Still it is stable. And how it is stable? Because it forms back bonding. We have boron ka empty orbital and fluorine ka lone pair, right? Goes to empty orbital of boron. So in that way, boron can complete the octet, and this is the concept of back bonding. Back bonding. Then we have, so it means number of molecules from the following which are exceptions to octet rule. NO2, H2SO4, BF3, CH4 में no, we have 8 electrons. कार्बन में CO2 में भी we have 8 electrons around carbon. SiF4 में भी we have 8 electrons. If we talk about ClO2 का let's see. Then PCl5 expanded octet है. BF2, yes, hypovalent. So total we have 1, 2, 3, 4, 5, 6. C2H6 no, CHCl3 no, CBr4 no, all 8 electrons. You can draw the structures. Right? So अब जैसे let's check for PCl5. तो PCl5 is PCl, Cl. So total 10 electrons, greater than 8 electrons. Similarly, BEF, less than 8 electrons, only 4 electrons, right? Now we have ClO2, right? ClO2. So ClO2 means double bond O, right? Double bond O. And now we have lone pair 1, 2, 3, 4, 5, 6, 7. Okay? So if I count the total electrons, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We can also write down the structure like this: ClO2 double bond O. So 1, 2, 3, 4, 5, 6. 3, 4, 7, 8. ठीक है, 8 मिनट. Cl, this coordinate bond, so 1, 2, 3, 4, 5, 6, 7. So here we have total 4, 5, 6, 7, 8, 9. So yes, right? So basically what we can write, total number of molecules which are exception to octet rule, that is equal to 6. Now next, number of compounds from the following with zero dipole moment is. Number of compounds from the following with zero dipole moment is. So obviously you have to calculate dipole moment. So HF ka to we have dipole moment towards fluorine side. The dipole moment is not equal to 0. H2, same atoms, bond is between same atoms, so difference in electronegativity is 0 and dipole moment is 0. If we talk about the H2S, right? If we talk about H2S, then what happens in H2S? Zero dipole moment? No, zero nahi hai. H, so dipole moment is towards sulfur side, so net dipole moment is there. So dipole moment is not equal to 0. So here we have H2. Then we have CO2. So CO2 again, dipole moment is equal to 0. net dipole moment, they are in opposite direction, so dipole moment is 0. NH3 though we have discussed many times, the dipole moment is not equal to 0. BF3, geometry is trigonal planar, so net dipole moment of these two bonds is in downward direction, and for this one it is in upward direction, so here dipole moment is 0. So CO2 0, BF3 0, CH4 is also 0, H H H tetrahedral. So for this towards carbon side, the dipole moment is towards here, net. Now for other two bonds, carbon side, the net is in this direction. So again, dipole moment is equal to 0. Okay. Dipole moment is equal to 0. एक minute. Yeah. So here dipole moment is equal to 0. CH4 is also the answer. CH4 is also the answer. Now we have CHCl3. CHCl3 में dipole moment is not equal to 0. नहीं होगा. CHCl3. CHCl, So for two bonds, dipole moment is towards chlorine side. So net is here. So here dipole moment is towards chlorine side and here hydrogen side. ठीक है? So it means one is going to be here, right? And one is going to be here. So that is not going to be 0, not equal to 0. For SiF4, so SiF4 it is going to be 0 because dipole moment is towards fluorine side. The dipole moment is equal to 0. For water, we know that is a polar protic solvent. The dipole moment is not equal to 0. BeF2. So BeF2 के लिए what we can say 0. So we have H2, CO2, BF3, CH4, SiF4 and BeF2. 1, 2, 3, 4, 5, 6. So total answer that is going to be 6. Right? So BeF2 0. ठीक है? So dipole moment is 0. Clear? So answer is going to be 6. That's it for today. I hope you understood each and every question. If you have any kind of doubt, you can write in comment section, and if you need any kind of help, okay, then you can also write in comment section. I will try to help as much as I can. So that's it for today. So see you in the next video, and in the next video we are going to discuss some questions related to thermodynamics. So before starting with the video, right, before starting solving the question, just try to revise the thermodynamics on your own. Okay, so bye, see you in the next video, take care.